Hi guys, welcome to another LER In electronics repair video. So this is part 3 with our graphics card. New day, new haircut, yeah. It was getting too long and it's too hot here. Oh man. So, couple of things, just one, apart from the haircut, I've repositioned the fluorescent lighting above the bench because somebody was saying the lighting wasn't very good. So I'm interested to know if any of you spot any difference with that. We can continue to move things around until we get it good, yeah. So other than that, this is our GTX 1030. Hopefully you watched the first two parts. So the first part, we figured out there was an intermittent fault. If you just flex the board slightly here and just very slightly, it'll work or not work. When it doesn't work, it's basically has a RAM fault. And then using MAT's software with this as a secondary GPU, because it doesn't give a picture when it's not working, we use the onboard video and I showed you how to figure out which RAM chip it is, and it's that one. Or at least that's what MAT tells us. Now, I mentioned at the end of the last video that this chip, all the tracks, and assuming the fault is a connection underneath the BGA, the tracks come down this way to the GPU. So these tracks, one end goes to the BGA and nowhere else, and one end goes to the GPU and nowhere else. So we need to remove one or the other, or at least reflow one or the other, to figure out, where the problem is. A bit of trial and error. But what I think I can do is if I remove the RAM chip first, which is the easier one to remove because we can do this with hot air, and I'll use a preheater. It was only a cheap one, makes it easier. We can get this off fairly easily and reball and put it on fairly easily compared to doing this one. And while I have the chip off, I can then measure in diode mode all the address and data lines which are going to here and see effectively if the reading is the same on each one. If I've got broken balls under here, I should be able to see that they're not the same, and that would probably tell me that the fault was definitely under here. So let's get this removed. Let's have a look to see if we can then determine whether the problem is under here, and whether it is or whether it isn't. We then need to reball this anyway to put it back on. But if the problem is under here, I will reball it, but I'll leave this off. We'll do this first and then put it on. So that's the plan. The thing that makes me think it might be a problem under the BGA is because by some coincidence the fault, if you like, the bad connection is on the corner of the GPU, and I don't generally believe in coincidences. Well, I do believe in coincidences because coincidences happen, yeah, but it makes me suspect that there might be some more sinister reason as to why it's the one in the corner. Because if the balls under here are going to fail, the chances are the corner is a very good place for it to happen. Yeah, so that's my reasoning. Maybe comments below, guys, comments below. But in the meantime, let's get this off. Now, I'm sure there are a few ways of doing this. I'll show you the way that I do it. Works for me. It doesn't necessarily mean it is the best way to do it, yeah? So the first thing you can see is that this area of the board, there's no components here. So when I lift it off with the tweezers, these tend to slide. So I'm going to try and get it so I effectively push the tweezers that way, and that means I'm less likely to disturb any nearby components. That's one thing, yeah? To do it, I'm going to get flux underneath the RAM chip. So this is NC559ASM. I just have my hot air on 420, 450, but I'm not going to hold it close or warm it particularly. I just want to effectively get the area a bit warm, and that flux will kind of disappear under the chip. Yeah, that's the plan with this. So we'll do that, and then we'll just work our way around. So we'll go to this side again, flux, and see if I can just get the flux to kind of like run under the chip. There's loads of it on the other side now, so I'll just turn it over and literally do the same thing that way. There's plenty of flux there. And we'll come in from this side. Okay. With a large BGA, like the GPU, I would do this going around twice. But with a small one like this, usually just that will do the job and get it under there enough to go all the way under. Okay, so that's our chip warmed, not particularly hot. And now we need to remove it. So I'm going to use the preheater to warm the board from underneath. We'll put a temperature gauge on here just so we can see what temperature it's at, and we will see if we can do it. We'll just move that out of the way a moment. This is my preheater, so it's a Carder 853B. You will find the link to this in the video description, and they are affiliate links, so if you do decide to buy one and you click on the link, I have them on Banggood, AliExpress, Amazon. Not all products are on all three, but where they are I put on Amazon UK and Amazon US. So you click on the link, you just pay the normal price you would pay anyway, and for clicking on the link I get a bit of commission. So yeah, if you want to help support the channel, that's great guys. Yeah, so we're going to use a preheater. We're going to balance the board on here, which will balance quite nicely. Yeah, and we're going to heat it up from below, so we'll just put the power onto the preheater, board on, and then we'll get the thermocouple so we can effectively monitor the temperature of the PCB. Okay, so I've put the thermocouple on there. You can see if I move away from the PCB, this is the ambient temperature in my workshop. The air conditioning has been on for about an hour and 20 minutes or so now, but it's pretty warm. We've had a lot of hot weather here, so we've had temperatures around 40 centigrade for about 3 weeks every day. And as is typical here, when the heat wave or Kalima ends, it doesn't all like turn to crap and thunderstorms. No, it just goes back to the normal nice weather of about 32 in the day rather than 42. Yeah, it just goes back to normal. It doesn't really do anything dramatic here weather-wise, which is nice. So anyway, it's warm, and we're going to warm it up a little bit more with this. So we'll switch the preheater on. There's no temperature setting on this. I mean, there's like a dial on the front with numbers on it, but they don't really bear any particular relevance to the actual temperature in my opinion. I'll get the chip over where the hot air is, which you can see is coming from here. Yeah, if I turn it up, you'll see it glowing. Yeah, so it kind of like pulses like that. So that's how it works. It's not a variable heat, it just effectively pulses, and you turn the dial and it pulses more often. Kind of pulse width modulation. Yeah. So you can see it's warming up, and what I want to do is to get the PCB over 100 centigrade, preferably 120 or something like that, and then we'll use the hot air, which is the quick 861DW, and we'll get this chip removed. I'll just get some tweezers ready while it's warming up. The trick with this, guys, is you don't rush. You haven't got to heat it up fast. Give it time for the heat to soak into the PCB. Yeah, I can get to the chip. To make my life easier at this point, I'm actually going to rotate it that way. You can still see the temperature gauge. It's just easier for me to come in from this side with the tweezers. And I say it'll tend to slide anyway because of the flux. So you can see it's warming up. I'll turn the dial, which you can now see, up a little bit, and we'll get the board nice and warm. Doing this is much better than just using the hot air, and these things are not expensive. They just make it much easier to do and better for the PCB basically. You'll see this will start to eventually smoke a little bit as we get enough heat into it. You'll also notice I put the thermocouple to one side, not there, so that I know this is going to slide a little bit when I pick it up. It's not going to hit the thermocouple. I have on occasion with the BGA rework machine actually had the thermocouple slide into where the chip came from and solder itself. Which you can unsolder with hot air, but you don't want it to happen. You don't want the thermocouple to slide under where the chip was and solder itself to the board. This is not a very heavy board, so it's warming up quite nicely, and I think we can probably get it up to about 120. Okay, it's close, yeah, it's close. So what I'm going to do now is to turn the preheater up to full and bring in the hot air as well. So I have my hot air, just untangle it from under the wires. I have the hot air, preheater up, hot air in, and we should be able to unsolder this fairly quickly. Yeah, there you go, guys. Preheater off, and I can now switch it to cold, so it's now blowing cold air. I have the chip here, you can see that came off nicely. I didn't really dislodge anything near to it, but we can let it cool down, clean it up, and we can have a good one. While it's still warm, you can see it's still 100 degrees. This is the perfect time to actually clean up the place where the chip came from. So we'll just get some leaded solder. I have a BC3 tip, quite a chunky one. Now effectively you're going to get like a blob of solder, which you're then able to float on the board over the, effectively hardly touching it, there's no pressure. I'm just literally floating this around the balls where it came off, and this effectively adds some leaded solder which will reduce the melting point. Okay, try not to dislodge any nearby components. That looked good. We can now add some flux, and we can use solderic. I use this one, Chemtronics size 4. Before I used this I couldn't do this, and now when I was recommended to use this I can. Normally I cut a small bit off the braid so you're not effectively sucking heat back up into this. All these things are on the affiliate links on this video, by the way. If you need to buy any, you just do me a favour, and doing yourself a favour, because it's good stuff. And now I can literally just float this little bit of braid over the chip, and this is just cleaning all the pads for me. You can probably see how they're coming clean. I'll just turn around a little bit. I don't actually use a fume extractor, but with this I would have been better just to put a fan so it blows the fumes away from me. Let's get rid of that bit of braid. Next time I will put a fan to blow the fumes away from me. Okay, a little bit more braid. Just get it into the position so it's not over the capacitors. One of the capacitors moves slightly, but I can sort that out. A little bit more leaded, sorry, a little bit more flux on the braid. Yeah, a little dab of leaded solder on the soldering iron and onto the braid. It's a little bit difficult to get to this end without effectively hitting the capacitors, but I think I've managed to do it. Okay, and I think I have actually dislodged one capacitor, but I'll sort that out. Okay, and that's quite clean. We'll let it finish cooling down, then we'll clean it up and see what it's looking like. I've cleaned the flux off. There's some balls along here that I haven't cleaned. You can see there, yeah. This capacitor got dislodged and this one disappeared. I mean, you can put Captain Tape around, which may help to stop this happening, but to be quite honest, it also prevents you getting heat properly into the board as well. It's not going to be difficult to do this. most certainly just remove this one, measure it, and then replace them both with the same. But we might have another problem with this, which is here, which looks like we have a couple of pads missing. Now, I didn't use excessive heat on this, and I'm wondering if this effectively is where the problem was to start off with, because flexing here was certainly causing it to fail. So let's get under the microscope. We can clean this up, and then we can have a better look at what's actually happening around here. We're under the microscope now. This is the chip which I removed, which I'll show you in a minute. This is the capacitor that actually moved, so it's effectively swung around, or it came from there to here. I had a look on the original video. I suggest you take photos before you do this, but I can refer back to the video, and then I can see there were two capacitors here. It'd be very simple to remove this one, measure it, and then just fit two. But that isn't the real problem. So the real problem is this. So this chip goes this way round, and if you can see down this edge here, I'll clean it up, but it's like there's a whole row of pads effectively missing down this edge, and at the same time there's one here and one here and one here. Now these pads obviously go somewhere. You can see there's a via there, there's another via here, there's a via here, so these definitely go somewhere, but they could be ground or power pins. You can see the tracks coming in under the chip and where they go to. Having said that, there was probably some internal tracks as well going here. We can find the pin out for the chip, but I think we would be extremely lucky if we could say that these are power or ground pins and they don't matter. But we can certainly check, which we will do in a minute. I'll clean this off, and then let's have a look at this. But this, to me, is too much of a coincidence that the problem is all down this edge, which is the closest place to where I was flexing, and somebody commented they thought it made sense it was down here. So to clean the RAM chip is exactly the same process as cleaning the PCB basically. You might need tweezers to hold it in place to stop it sliding around when you do this, but usually it stays put. This is just the lid off an old satellite receiver. It just saves me getting, you know, hot things on the ESD mat on my bench. So that's why I use this. So we'll get a bit of flux on here, and we'll do the same thing. We'll get a good blob of solder on the end of the iron. I probably will just hold this down with tweezers, and then we just effectively just hover this around the chips. We're not really, well, we are kind of touching it, but we're putting no pressure. We're just letting that ball of solder move around the chip, yeah, and we'll just turn it around. We can do the same on the other side. A little bit more solder. In fact, I'll get some fresh solder. Okay, and we'll just hover our ball of solder over the chip. Okay, and then we can do the same as we did before. A little bit of braid, a bit of fresh solder and flux. So again, we take a small bit of braid, okay, put it onto our chip. I then put a bit of fresh flux onto the braid. Okay, clean the soldering iron, and I get just a little bit of solder on the tip of the iron. That's all I need, and then we can just effectively stick it onto the braid, and we can now, again, I'm not putting any pressure, I'm literally letting the braid glide across the chip, and you can see that the pads are coming in nice and flat and clean. Okay, it's stuck down actually with flux now. I don't need to use the tweezers, it's glued itself down with flux anyway. Let's go down this side and have a look, and I think you can see straight away what the problem is. Now it's cleaned up, we can see what's happened. So this is the edge of the chip that goes to here, and you can see all the way down this edge the pads are basically missing. I mean, we can scrape away at one, yeah, but it's like something corrosive has got under it. It's all on that edge as well. I mean, there's two reasons really why this had happened. One, that there's some sort of problem under the BGA to start off with, or two, that you didn't heat it up properly and you tried to remove it while these balls were not liquid. But if that happens, when you flip the chip upside down, and I showed you before I cleaned it up, the pad is effectively stuck to the ball. You can see the ball is still there, and the brownish colour, sort of similar colour to this, which is the pad upside down stuck to the ball, and that didn't happen. It's like they'd basically gone. I think something was corroded under here, and once I heated it up, it just went. Yeah, so that's the problem with the chip. Now we can get a chip, I'll show you in a minute, on AliExpress. We can get chips. The other thing is, what about the PCB? Is it repairable? Well, actually the answer is yes. You can see then the three pads which have come off are all next to a via, so the via effectively connects to the pad. So what we can do here is we can scrape away. I might need something sharper than this, but effectively I can scrape away at this until I come to the metal. Yeah, you can see it there. Okay, I've got the metal, the copper, and I can do the same with the other ones. I mean, this is already a little bit of solder around there anyway. This one again, we can just get at this a little bit. You can see metal there now. Yeah, you can see it. Okay, so we can do that, and then we can actually buy. They call them Wiley Dot, and I think there's another brand as well. Actually, I think there's at least a couple of brands of these, but they basically solder pads. In fact, you can even see the copper slightly underneath that one where it's come off from. So I'll show you what we need to fix this, and then it really is down to the owner what he wants to do with this graphics card. These are the chips. This one, K4G41325FE-HC25. I can get them from this supplier, SUHMS, who I've found to be very reliable in the past, to be quite honest. I've ordered BGAs from these guys before and they work. So one chip, €4 plus the postage, like €5. To be quite honest, if I was ordering, I would say to the owner, order 2 of them just in case something goes wrong. Yeah, so you're looking around €10. I mean, I can order 1, but personally I would always order 2. Yeah, so that's that. This is the Wiley Real Life Solder Dot Repair Welding. You can do this with bits of wire, but there's not much space under there. It's much better to do it like this. So effectively this has like a copper sheet you peel off, and then we have pads with little sticks on them, yeah, as you can see, and we can effectively glue one of these where the missing pad is. So we use the UV active glue, effectively glue it down, and then the little stick we can cut off to whatever length we want, and we can solder that back to where I was just scraping away at the via. Yeah, so we can replace the 3 pads. Now this is going to be another €4 or €5. So you're looking at like €15 worth of bits. So we know the options then, really. If we get 2 of the chips, which I always tend to do that just in case something goes wrong with the first one, then you're looking at €10, another €5, €15 for the kit to fix the stuff, €50 for my time to do the job, and I'm confident that that'll work. I mean, it's fairly obvious now where the problem was all the time, because this just doesn't happen unless you really are not experienced with your technique of removing these. And even when you're not experienced with your technique, it doesn't kind of do it in that way. So you'll see the brown bits on here, which is the pads stuck upside down on there, which we didn't have. So there you go, guys. It's repairable. It's whether or not the owner wants me to do it and pay that price. Otherwise, the other options I mentioned in part 1 are still available. If he wants to let me have it for spares or repair, I'll give him a little bit of money for it. It has a good GPU on it, even if we can't fix this. So it's a nice donor board. But at the moment, that's what it needs to be repaired. So it's going to come in at well, 65 plus return postage. It's probably, to be quite honest, about the value of the card, but I can't do anything much about that. Yeah, you can't do more than that. I think we've proved at least 2 or 3 things here. One is that we can see what was wrong once we removed that. I would have liked to measure, using diode mode, all the resistances on the tracks to see if they're the same, if the fault was under here, but 2 reasons I've not done it. One is I can't find a data sheet for the chip, so I don't know the pin out, although it's possibly standard for GTX5, which is what I think it is. And 2, we have such an obvious fault here that it doesn't really see much point in doing that. Yeah. But what I can do just before we go is just check at least the ones I can see if any of those read different in diode mode. I can visibly see a lot of tracks going under here. So let's just check them anyway, and then the owner can have his say. We're back under the microscope and in diode mode, so let's have a look. So I'll just connect to ground, and what I want to see is whether all the ones where I can see the tracks coming up have the same reading basically. So that one's 395. That's close enough. I'm not expecting to be exactly the same. Yeah, 391. There's another one here. 380, 390. Yeah, so they're basically the same. So all I need to do is just go around all the various pads and have a look to see if any of them are different. Okay, and we can see they were all the same. So that's good. That suggests the connections under here and the memory controller is good. That then is as much I can do for now. Part 3, still not fixed. We certainly know where the problem was, for sure. And what have we learnt? Well, I think we've learnt that things don't always go to plan. Yeah, things do not always go to plan. When you're doing this sort of work, this will happen. And this will happen if there's a problem with the PCB to start with. But when you're learning, this will happen because of bad technique, and it's something you get used to. I'm confident in my technique now, which is why I'm confident I didn't cause this problem. But hey, you know, comments below, guys. Yeah, comments below. Secondly, it proves something else. If any of you doubted this, I don't think any of you did doubt this. This channel is real, yeah. This channel is real, and I suspect it's one of the only ones on YouTube. There's no script and no rehearsals, yes. And what happens happens, and what you see is what you get. Yeah, learning electronics repair, that's how it is. We'll have to wait to see then what the customer wants to do with it. You may or may not see a part 3, but if you don't, I'm sure you've learned quite a lot of things. And if you do, well, I'm sure you'll learn 1 or 2 tricks more. Okay, guys, it's the weekend. That's it for me, and I'll see you all soon on another Learning Electronics Repair video. Ciao for now, guys.